Hey everyone, welcome back to another fun and exciting Algebra 1 class. Today we are going to be continuing along. We'll be on lesson 8.5 today, and that's going to start off on page 289 in your books. Down at the screen, and you're going to see that I have the square root of 9 over 64 written down. Now, in a few lessons ago, we learned how to do this. We learned the quotient rule. So if we take this, it's saying the same thing as the square root of 9 over the square root of 64. We know the solution to both of those. The square root of 9 is 3, and the square root of 64 is 8. So our solution is 3 over 8. Now, that's great, and it's easy, and it's no problem. But what happens when the denominator, especially the denominator, but we can have some problems in the numerator as well. But what happens when the denominator doesn't come out evenly? Look what I have written down here. If the denominator has an irrational root, now this one that we just looked at was not irrational, that is even and that comes out to 8. But what happens if it's irrational? So what do you need to do? Then you need to multiply both the numerator. This is important, that word both, the numerator and the denominator by the same thing. Okay? What are we going to multiply it by? Well, we're going to figure that out in just a second. What do we multiply it by? The same thing in order to cancel the root in the denominator. In other words, you cannot have a root in the denominator. That is what's called irrational fraction. You must rationalize the denominator. All right, so let's try it. Now what we have here in this one is we have the square root of 3 over the square root of 8. Now we have a problem. We don't know what the square root of 8 is. The square root of 8 is irrational. Here's our problem. This has an irrational denominator, and in math you can't have this. This is a problem. We need to fix this. How do we fix it? Well, it says to multiply both the numerator and the denominator by the same thing. Okay? So let's multiply it by 2. Let's multiply it by 5. What are we going to multiply it by? You can't just guess, okay? You can't just say, I'm going to multiply it by 2. What are we multiplying it by? The same thing in order to, what are we trying to do? We're trying to cancel the root. We're trying to cancel the root. So here's what we want to do. Here's what we're focused on. We're focused on taking this number to a perfect root. What does that mean? Well, let's write our perfect roots. So 4 is a perfect root. 9 is a perfect root. 16 is a perfect root. 25 is a perfect root. 36 is a perfect root. 49 is a perfect root. 64 is a perfect root. Okay, we'll stop there. We want to find a factor, find something that we can multiply times 8 that will give us one of these numbers. Okay, so can we multiply anything by 8 to get 4? No. Can we multiply anything by 8 to get 9? No. Can we multiply anything by 16, by 8 to get 16? Yes, we can. If we multiply, watch this, if we multiply the square root of 8 times the square root of 2, now that's important. We're multiplying by the square root of 2. What is that going to give us? That is going to give us the square root of 16, because we have to multiply roots by roots in order to get another root. Okay, so make sure that you multiply by the square root of 2. Don't just multiply by 2, the square root of 2. Now, let's go back to what this said here. It said we have to do it both the numerator and the denominator. We only did the denominator. So let's come back here, and now we have to also multiply this numerator by the square root of 2. What do we get? 3 times 2 is square root of 6. Now let's look at something. I want you to see something. I want you to see that we just didn't like make up something, or we didn't change the value. What is this right here? Well, that's a fraction. What is the square root of 2 over the square root of 2? That equals 1. Remember, anything over itself always equals 1. 3 over 3 equals 1. x over x equals 1. Anything over itself always equals 1. So what did we multiply by right here? Yes, we multiplied by the square root of 2 over the square root of 2. But what did we really multiply by? We multiplied by 1. Okay? And when you multiply by 1, you are not changing the value of this. So take a look at this. Here's what this means. Square root of 3 over the square root of 8 is equal to, notice that equal sign right there. Because we multiplied by identity, which is 1, we got square root of 6 over square root of 16. In other words, we did not change the identity of that fraction. That fraction remained the same. We just multiplied by 1. Square root of 2 over square root of 2 is like multiplying by 1. And that gave us a new fraction. What was special about this fraction? The denominator was special. Why is it special? Because now it's over here on this list over here. Okay? We want it to be on that list. Why? Because now what can we do? What is the square root of 16? The square root of 16 is 4. And this one can't solve, so it just stays square root of 6 over 4. Now we're done. Now we're done. Why are we done now? Because we have the denominator is not irrational anymore. The denominator, we were able to rationalize it. That's the point. That's what we're trying to do. You have to rationalize your denominators. Okay? Let's do another one. This one's just got letters in it. So this one's a little bit different, but really the same thing. Now, this equals square root of x squared over the square root of y. We need to rationalize the square root of y. We can't have it in the denominator. So if we multiply, whenever we have a letter, we always just multiply it by itself, and that will square it if it's a square root, which this is. These are 2's here, okay? So they're not written in there, but they're understood. So we want to multiply it by itself, square root of y. If we multiply the denominator by square root of y, we have to multiply the numerator by square root of y. All right, so let's do the denominator first. Square root of y times the square root of y is the square root of y squared. Now that's rational. That solves out. What does it solve out to? That solves out to the y comes out, so it's just y. Okay. Now up here, we just multiply right here. What do we get? Square root of x squared y. This x squared solves out. The x can come out of that. So we're going to have up here, we're going to have x square root of y, and that would be your answer. Okay? So with the letters, it's the same process, but it just kind of solves out just a little bit differently. Those examples are both in your book on page number 290. Page 290, you can see those. Okay? All right, let's look at one more here. Now let's do one with a cube. This one's just a little bit different because now we have a cube root. So that means that we have to take this to a perfect cube, not a perfect square. What do I mean by that? Well, let's break it down first. We have the cube root of 8 over the cube root of 5. This is irrational because you can plug that into your calculator and you'll find that there is no cube root of 5. So what do? This time we're going to write our perfect cubes down, okay? So what are the perfect cubes? Well, the first one is 2 times 2 times 2, so that's 8. This is in your book. So some of you are getting lost right now because you didn't memorize table 2. I told you last class that we were using table 2, and you still didn't memorize it. So here we are again in this lesson using table 2. It's actually table B, I think. Back on like page 273 or something like that. It's back a ways. Find table B in your book, okay? When you find table B, it shows you all the squares and it shows you all of the cubes. Use that table to solve these, okay? So 8 is a perfect cube. What is the perfect cube of 3? Well, that's 27. What is the perfect cube of 4? Well, that's 64. What is the perfect square of 5? 125. Now, I want you to notice, Sometimes the perfect cube is just that number cubed. So 2 times 2, or 5 times 5 times 5. That's what this is in this case, because watch. Can I use anything else? Can I use 8? No, 5 doesn't go into 8. Can I use 27? No, 5 doesn't go into 27. Can I use 64? No, 5 doesn't go into 64. 125. So here's what I want. I want this to be 125. I want this to be the cube root of 125. What do I have to multiply times this to get to the cube root of 125? Well, I have to multiply this times 5 times 5. Or I have to multiply this times the cube root of 25. And then that's going to give me the cube root of 125. Why do I want the cube root of 25? What's my goal here? My goal is to get rid of this cube root in the denominator. Okay, that's my goal. That's what I'm doing. Notice if I multiply the denominator by the cube root of 25, I must also multiply the numerator by the cube root of 25. Okay, so this times this gives me, or 5 times 25 gives me the cube root of 125. 8 times 25. I don't know what 8 times 25 is, but that's why we have a calculator. So we come over here. 8 times 25 equals 200. All right, so this is going to be the cube root of 200 up here. Now, we're not done yet. We have to simplify this. What is that simplified? Well, what is the cube root of 125? If you look on table B, the cube root of 125 is 5. Okay, let me write it down here. So 5 is our denominator, and this, the cube root of 200, is our numerator. Now, what we have to do is we have to ask ourselves, can we simplify the cube root of 200? Okay, can we simplify it? My guess is yes, we can, but maybe not. I don't know. Let's see. Go ahead and take out our calculator. What we want to do here is we want to compare these. Does 8 go into it? Does 27 go into it? Does 64 go into it? And that's where we'll start. So let's go to the calculator and let's say 200 divided by, let's start with 64. I don't think that's going to work, but we'll try it. No, we get a decimal. Okay, that didn't work. So let's try 200 divided by 27 to see if that one works. No, 7.4, another decimal. Well, we only have one left, so let's see if that works. 200 divided by 8 equals, hey, bingo, 25. So this one, the cube root of 200, solves out to the cube root of 8. That's this one right here. That's the one we used. And that comes out to, on our calculator, that gave us 25, the cube root of 25. Okay, and so now what do we do with this? We solve this out. What is the cube root of 8? Well, it's 2. You say, what are you talking about? It's 2. You didn't memorize the chart. Look at table B. Come on, look at table B. The cube root of 8 is 2. That's how you solve those. You have to have those memorized. Okay, that's just all there is to it. Please memorize those. Now, yes, you can plug it into your calculator, but memorize those. It will help you immensely. So what is left up top right here, we solve this out to 2 cube root of 25. 2 cube root of 25. And what's on the bottom? 5 is on the bottom. Okay? Now you can write that 2 different ways. You can write that like that. If you look in the book, they wrote it just with fraction. Okay, so they wrote 2 over 5, and then basically they wrote cube root of 25. That's the same thing. Okay, you say, are you sure it's the same thing? Yes, I'm sure it's the same thing. Why? Because what is it like saying? It's like breaking this down into cube root of 25 over 1. What is the cube root of 25 over 1? It's just the cube root of 25. So you could write it like that. Cube root of 25. Either one of those ways is acceptable and actually is fine. They both work, whichever way you want to write that. Okay? All right. Well, that's all I have for you. There's some other ones there you can look at. Try some of those practice problems. Work through those. And if you have any questions, you can always drop them there in the comments, or rewind the video back, watch it again, see if you can learn how to do some of these. Okay, we'll see you later. Have a good one. Bye-bye.